Critical path. Let's have a look at some definitions. So float time equals the latest finishing time minus the earliest starting time minus the weight of the edge. Critical path is the longest path between the start and finish vertices, usually found by looking for activities with a zero float time. Critical step. Any activity on the critical path is called a critical step. Delay to a critical step will cause delay to the whole project. The critical path is the longest path from the start vertex to the finish vertex. It represents the sequence of activities that are time critical. In that, any delay to these activities will cause a delay to the entire project. So if you are looking at an activity that is on the critical path, you can't delay any of those activities. Otherwise, it will delay the finish of the whole project. There will always be at least one critical path. There can also be more than one. So the float time formula is float time equals latest finishing time minus earliest starting time minus weight. Now we know that our latest finishing time is the number that we put in the box when we do our backward scan. And the earliest starting time is the number we put in the box when we do our forward scan. And then our weight is the number on the edge. So if you do a forward scan and then a backward scan, you have all the information you need to calculate the float time of each edge. So your process whenever you see a network would be to do a forward scan, then do a backward scan, and then you can calculate your float time. So example 1, if we have a look at this network, where would our critical path be? Our critical path would be BC. It can't be AC because AC only takes 3 minutes. But BC takes 5 minutes. And remember, the critical path is the longest path from start to finish. So the critical path of this network would be BC. Let's have a look at this example. Okay, so from this network, determine A, the earliest starting time of each activity, which is a forward scan. B, the latest finishing time of each activity, which was the backward scan. The float time of each activity, and the critical path. So you can see in the diagram, I've already done the earliest starting time and the latest finishing time. The earliest starting time is in the left-hand box. The latest finishing time is in the right-hand box. So you should be able, now we'll calculate our float time. We do that by creating a table. Okay, so I've got my activity, A, B, C, D, and E. And then I have my calculation, which is latest finishing time minus earliest starting time minus the weight of the edge. And then my float time is whatever that equals. So if we have a look at activity A, my latest finishing time is 10. Okay? I can't finish A any later than 10 or it will delay the whole project. My earliest starting time is 0 and my weight is 10. So 10 minus 0 minus 10 equals 0. If we have a look at B, my latest finishing time is 25. My earliest starting time is 10. So 25 minus 10 minus my weight of 15 equals 0. If we have a look at C, my latest finishing time for C is 34. My earliest starting time for C is 0. And my weight of C is 5. So 34 minus 0 minus 5 equals 29. If we have a look at D, activity D, my latest finishing time is 35. My earliest start time is 25. And my weight is 1. So 35 minus 25 minus 1 equals 9. And then if we look at E, Our latest finishing time is 35. Our earliest starting time is 25. And our weight is 10. So 35 minus 25 minus 10 equals 0. Now looking at this table, we can see that our critical path will be where we have a float time of 0. So our critical path will be A, B, E. Now I want you to complete the textbook of exercise 10D, page 444. I have added 2 questions on the end of this that were not included in your notes, and that's question 11 and 12.